This is problem number 5 from the 2022 AP Stats free response set. This question kind of makes its way into several different areas of the course, and it involves lowering blood pressure. So researchers are conducting a study to investigate whether you get a greater reduction in blood pressure for people who consume dark chocolate, which contains flavonoids, than people who consumed white chocolate, which does not contain those. So 25 healthy adults agreed to participate in the study and add 3.5 ounces of chocolate to their daily diets. Of the 25 participants, 13 were randomly assigned to the dark chocolate group, and the rest were assigned to the white chocolate group. All participants had their blood pressure recorded in millimeters of mercury before adding chocolate to their daily diets, and again 30 days after adding the chocolate to their daily diets. So the reduction in blood pressure, so blood pressure before minus blood pressure after, for each of the participants in the two groups is shown in each of the dot plots. Part A asks us to determine and compare the medians of the reduction in blood pressure for the two groups. So, for the dark chocolate median and the white chocolate median, it's pretty simple to do this with the dot plot. Everything's already in order. In the dark chocolate group, we had 13 total people. So if I just crossed out 1, 2, 3, 4, 5, 6 data points on the low end, I could do the same and work in 6 data points from the high end. I should have this one right here with a value of 7 as my median. For white chocolate, I have 12, so I would have to cross out 6 on the low end. So there's 4, 5, and 6. And I would also have to cross out 6 on the high end. So there's 1, 2, 3, 4. All of those will get crossed out. So what I would actually have is I'd have a -2 and a 2 sharing the middle spot. And when that happens, you would take the average, and the average of -2 and 2 is, of course, 0. Now we are asked to not only determine them, but also compare them. So when I compare them, I definitely have to do this in context. Anytime you're asked to describe, compare, and in FRQ on the stats exam, it's almost always the case that one of the requirements in order for you to receive the most possible points for the problem is that you responded in context. So you definitely see me talking about the median decrease in blood pressure for dark chocolate was 7, and I also included the units there, while the median decrease for white chocolate was 0. Median decrease in blood pressure was significantly larger for the group eating dark chocolate daily than the group eating white chocolate daily. So I definitely talked about the two groups. I talked about the units. I did that in context. You don't just want to say it was bigger for dark chocolate and leave it at that, right? Do take a little bit more time, a little bit more detail. Something that's pretty easy to do, but have to remember to do so. Part B says that the researchers found that the mean reduction in blood pressure for those that consumed the dark chocolate is 6.08 millimeters of mercury, and the mean reduction in blood pressure for those who consumed white chocolate is 0.042 millimeters of mercury. One researcher indicated that because the difference in sample means, so X bar dark minus X bar white, is 0.566, greater than 0, there's convincing statistical evidence to conclude that the population mean blood pressure reduction for those who consume dark chocolate is greater than for those that consume the white chocolate. Why might the researchers' conclusion based only on the difference in sample means not necessarily be true? Well, the big thing that the researcher never did was use an inference procedure, right? You would want to run a significance test for a difference of means and develop a p-value that allows you to reject a null hypothesis in order to develop this sort of conclusion. And that definitely was not done. So I'm basically describing that they should have been using an inference procedure here. And then in addition to that, one of the things that inference procedure would involve would be that the sampling distribution have an approximately normal shape. And for a situation involving means, in order for the sampling distribution to have an approximately normal shape, we would typically like our sample sizes, in this case they're 13 and 12, we would typically like our sample sizes to be above 30, because then the central limit theorem is going to ensure that the sampling distribution for each of the samples, the dark chocolate group and the white chocolate group, is going to be approximately normal. These sample sizes are significantly beneath that value. So it's quite possible that just through sampling error, just by chance, more people that had more room to reduce their blood pressure, a higher initial blood pressure, were placed into the dark chocolate group than were placed into the white chocolate group. So sampling error could have contributed to this due to the low sample sizes. But if you're going to try to say you've got a statistically significant result, you better have some statistics backing that up and not just a calculation here. We've got to use an inference procedure. And then in the last part of this, they say that a simulation is conducted to investigate whether a greater reduction in blood pressure for those in the dark chocolate group than for those in the white chocolate group. The simulation was conducted under the assumption that no difference exists. So this is kind of, maybe a little different, but if you're assuming something is true, you're basically making a null hypothesis, right? So we're assuming that there's no difference in the mean reduction in blood pressure between the two groups. The results of the 120 trials of the simulation are shown in the following dot plot. So we've got a lot bunched up at 0. That makes sense if you're assuming that there is no difference in means. You should have most of the data bunched up near 0. Now what part C says is to use the results of the simulation to determine whether the results from the 25 participants in the study provide convincing statistical evidence at a 5% significance level that adding dark chocolate to the daily diet will reduce blood pressure greater on average than adding white chocolate to the daily diet. Justify your answer. And so what I know from back in part B is that from this study, the 25 participants in this study, the difference in means was 0.566. 0.566 is somewhere in here. We have exactly 3 of the 120 trials within the simulation as extreme or more extreme than the difference in means that our study actually produced. So if we're assuming that there is no difference, and this is the way the results should shake out, only 3 of the 120 trials got a result as extreme or more extreme as the one that we got. And if you think about that phrase, it's the second time I've said it in the last few seconds, that should hopefully get you thinking about a p-value, right? That technically what a p-value is the probability that you get a result as extreme or more extreme as the one that your sample generated. In this case, the probability that we get a result as extreme or more extreme as the one that our study got is 3 out of 120, 0.025. And since 0.025, which is essentially our p-value, and although it wasn't determined the traditional way within the simulation that we're dealing with right now, this is acting like a p-value, right? The probability that we get a result as extreme or more extreme than the one that we got is 0.025. That is beneath our significance level. So we have significant evidence suggesting that what was assumed, the assumption was no difference exists. We have significant evidence suggesting that what was assumed actually is not true. So the difference between the two groups, the mean decrease in blood pressure between the two groups, it's not 0. So this suggests that adding dark chocolate to the daily diet, on average, will have a greater effect on reducing blood pressure than adding white chocolate to your daily diet.